Hello, I'm Alex Field. I work for NBC Universal and Sky. I work on OTT apps such as Peacock, Now TV, Sky Showtime, Showmax, mostly in the JavaScript playback side of things. So that's covering your web browsers, as well as everyone's favorite living room devices, smart TVs, game consoles, all the fun ones. So I've worked in this area for almost a decade now, and my colleagues, and during that time, my colleagues have seen all kinds of weird and wonderful behavior on these devices. Some of the most frustrating of that behavior is when the players on those devices are lying to you. So you've all been there, watching something online, and suddenly it freezes. There's no buffer icon, there's no error, it's just stopped playing. But then you look at the progress bar and it's still moving along as though it's playing out, and the player is lying to you. It's very frustrating. So I've got just a few minutes today to talk about one of the ways that we try and guard against this behavior and stop it getting to our customers. So let's first start off by looking at what a naive automation test might look like on a front-end application. You set up some scenario, and then what we care about for this talk is the assertions. You start making some assertions. Now, in the front-end application, you would typically make assertions against things on the page. What does a text box contain? Is an icon visible? But it's less obvious what you should do on a video app, especially as some of the devices we support, you don't have access to the surface that the video is rendered onto. So the temptation is to make assertions against the APIs and data that's coming out of the player. So let's have a quick look at what that actually looks like. So here's a snapshot of a test at the time the assertions are being made. And you can see the data is looking pretty good. And the test passes, hooray. But what happens in that scenario I spoke about where actually this content froze 20 seconds ago? But the progress events were still coming through and the current time was still being updated. Of course, the test still would have passed, even though the content was not being updated. Well, what else could have gone wrong? I mean, what if the bitrate was dropped massively, but there was a bug that meant that information was not relayed through the data available on the player? Of course, the test would have still passed. What if it was rendered incorrectly? What if there was a user interface issue and the video wasn't rendered at all? It was rendered somewhere behind the application. The test would have still passed, because at the end of the day, a test that tests against player APIs is only testing what the player thinks is going on, rather than what the user is actually seeing. So of course, why don't we test what the user is actually seeing? But how do we go about doing that? So on some modern browsers these days, you have ways of capturing snapshots of what's being displayed on the page, or maybe there's APIs built in at the JavaScript level. But we support devices that go back almost 10 years, which means they're running browsers from 12 years ago, and they just don't support these new APIs. So why not use a capture card? You probably have some success with this, but it's not going to work for smart TVs, don't have a way of connecting a capture card up to it. And both of these methods suffer from the same thing, that if you're doing any tests that cover any DRM aspects of your playout, you're probably going to run into some kind of issues, or at least you should. So why don't we think outside of the box and just stick a webcam in front of the monitor displaying what your device is, or in front of your smart TV. At the end of the day, it can see anything that a human can see, so you'll be able to capture what's being displayed on the screen. And it's not impacted by any of that DRM stuff. You can attach it to a cheap bit of hardware that can then do some kind of analysis of what's going on. So how does that end up looking? Well, you end up with some low quality, low resolution, blurry image that suffers from some ghosting, and not fantastic. So realize it's going to be an uphill battle if we tried to use real content to try and write these tests, because the poor little Raspberry Pi just doesn't have the processing power to take this image, clean it up, and compare it to the source material to try and extract useful information, such as where it appears, where this frame appears within the source content, or what bitrate it's available at. So why don't we make our life easier and make our own test content that is easy to read? So we started off by thinking, well, what's easy to read with our webcam, our low-resolution webcam in front of our device, even at the lowest quality available in our manifests? Why don't we just stick some big blocks of colors up on the screen? So started off, the first 5 frames are represented by 6 red blocks, the next 5 frames are 5 red blocks and a green one, and so on, so that we can uniquely identify these groups of frames within the content. And now we can take a picture of this and easily use simple image recognition, pick out those colors, and work out where we are in the content. And that's great for testing all kinds of basic features, sequential playout, seeking, bookmarking. What else can we test while we're here? What about ABR? So ABR is an interesting one. Even a human tester looking at a stream might struggle to determine what the quality is, whether it's the highest bitrate step in the ladder or the next one down. So how are we going to capture that with the webcam? Especially difficult as obviously you would usually use the same source content for each bitrate available in your stream. But as we're making a mock stream here to make our life easier for testing, why don't we just have separate sources for each of our bitrate variants, each with a unique block of color on it, so that when we take a picture of it, even the lowest quality bitrate variant, we can easily read it off and see exactly which bitrate is being displayed on the screen right now. So what other features do we have? What about CDN switching? So we have our content available via multiple different CDNs. It allows us to do all kinds of cool features, such as CDN failover. If there's an issue with one CDN, we can try to see if the other one fares any better. But of course, you normally have the same source content on each CDN. But again, we're doing these mock streams. We're not really testing the full end-to-end journey. We're focusing in on testing the player functionality. So why don't we just have different source content for each CDN as well? And now we can determine what's on the screen, where it actually came from, and we can test these features such as CDN failover. Finally, what about ad insertion? Can't miss out ad insertion, very important topic for players these days. But your temptation would be just to take your new test content stream, snip it up into different versions, maybe a 5-second version, 10-second version, and then that will allow you to test your dynamic ad insertion. But of course, you're going to have the problem that you won't be able to tell what's on the screen right now, whether it's pre-roll 1, pre-roll 2, or mid-roll 1, or the main content. So of course, you need multiple different unique test content, each with more unique identifiers inside them, so you can tell exactly what kind of content is being displayed right now. So now we've got this test stream where, with our cheap camera and our cheap Raspberry Pi, you can take a snapshot of what's on the screen right now and easily be able to tell where within the stream this frame is from, what time position it is, what quality level it's being displayed at, what CDN it came from, and also what the content actually is, which advert it refers to, or is it the main content being displayed. And the key thing is that information is all coming from what is being displayed on the screen, not from what the player thinks is being displayed on the screen. So how does it come together? So you have your test, like on that first slide, and at some point you're going to make some assertions. When you make the assertions, camera can take your picture, use some simple image recognition, like the hello world of image recognition to pick out the key bits of information, those big blocks of color, combine them together to get you the data. And whilst this data looks the same as what you might have got on the first slide, the reality is it's coming from what's actually displayed on the screen, so it's very different. Okay, so let's see what it looks like in action. There's going to be a lot going on here, so keep an eye out for the arrows. So we're going to start off with a couple ad breaks. So you're going to see it transition from one ad break to another. You'll see the asset ID change. And now it's going to transition from the second advert into the main content, so the asset ID is going to change again. Now once we're on the main content, there's going to be a problem. The quality is going to drop massively. So as a result of the quality dropping, we're going to switch from one CDN to another, so you're going to see the CDN ID update. And now that it's updated, the quality is going to recover, and it's going to go up through the different steps on the ladder and go back up to the highest quality. Meanwhile, whilst that's all been happening in real time, or virtually real time, we've been capturing all this data, which is now available within our test suite for us to make assertions on. And just to repeat myself, the key thing is all of this data is now from what the user is actually seeing on the device, not what the player is reporting that the user sees on the device. And on some of our devices, that's definitely not always the same thing. And yeah, that's it. That's all I really had time to talk about today. So testing video apps is hard. You need all kinds of tools to cover off all kinds of different scenarios. This is just one piece of that puzzle. And whether you've got your own in-house player, an open source player, or maybe a player that comes from the device, maybe by the manufacturer and some kind of native player, the reality is there's a good chance that player might be lying to you, and you should have at least some coverage to make sure that it's telling you the truth. Thank you very much for your time.